My name is Luka Mustafa and I'm the developer of KORUZA, a 3D printable wireless optical system that connects buildings up to 100 meters apart with 1 gigabit capacity. This system is designed to be used by home users to connect to their neighbors, get gigabit capacity to their homes without actually digging up the road and laying fiber, for community networks to boost the capacity of their network, as well as by researchers and universities to study free space optical networking and have a platform to test their ideas on. As you can see in previous videos, KORUZA has been developed over the last year to be suitable for open source release and ready to be used on a wider scale. We are launching the worldwide experiment for KORUZA at the moment, so we can all together test how well it performs over a longer period of time in various conditions, locations, and deployment scenarios. So we are calling for your participation in this experiment to deploy KORUZA units, so one link of 50 to 150 meters, along with all the test equipment and sensors required to find out in which cases the link fails, how does the weather affect it, and are there any design flaws that we have to fix in the future. So by participating in the experiment, research organizations, community networks, or even individuals can make really good contribution to this project supporting further development and experimentation. So we are making available a limited number of experimental deployment sets. So this consists of 2 KORUZA units, test devices on either side, which are routers that generate traffic and test for packet loss, and a huge range of sensors that helps us see when the device fails and exactly what's the cause of it. So from sensors on the optical side, measuring received power, transmitted power, and all the receiver properties, to environmental sensors like temperatures, pressure, humidity, even ambient light, along with a weather station like this. We connect all of it together into Wayland, Slovenia system for network monitoring called Node Watcher, and collect data in real time to have a good set of measurements to see how the weather affects the system and what are the failures of the system itself. Now, this KORUZA Generation 5 prototype is currently ready to be produced in a smaller volume. By participating in the experiment and sponsoring a deployment, you will help us also to prepare and allocate all the time needed for releasing the system open source, preparing the documentation, and making it ready for the world. So research institutions can get a set of units to deploy along with all the sensors to test immediately, thus create a baseline to see how well the system as such performs. And later this fall, when the system is going to be released open source, they can start building their own units, improving, implementing other solutions, and comparing it to the baseline. All the units within the experiment will contribute to the open data set that will be made widely available, so anyone can actually get all the raw data, perform studies and measurements on it, either for the free space optical channel or for the device itself. Over the course of 12 months or 6 months, how long each unit will be deployed, we will also test alignment algorithms, so actively tracking devices, battling thermal expansions and other problems. This Generation 5 prototype is a more integrated and more stable version of the previous developments, about which you can find quite some information now. The prototype as such is very simple. It consists of the main unit, which contains the optical lens for focusing, media converter, and the SFP for the optical communication, 3 stepper motors, 1 for controlling the focus and 2 for moving the unit back in the XY direction and thus aiming it. It is connected to a control electronics board, which is based on ARM, so it's a TVC launchpad, interfacing motors and sensors. It is connected via USB to the test Wi-Fi router that generates traffic, collects measurements, and sends it to the data collection system, along with measurements from the weather station and other sensors. Now, this system very simply just slides into the aluminum casing. There's a cover at the back housing the electronics. The best way to mount the system is just putting it somewhere on a roof, mounting it on a wall or a sturdy railing, and doing the same on the opposite side of the link. That's all required to set up the experiment and getting this units. So feel free to contact us if you would like to participate in the whole experiment, support our cause by donating or supporting the deployment on some other location if yours is not sufficiently suitable for a case like this. For more information, please see the website, contact us on the mailing list, or directly via mail. Thank you.